Let's get started then. All right, it is wonderful to see you all here today. It's delightful to look out and see your shiny, happy, smiley faces. I'm sure we're going to have a lot of fun. I hope so anyway. It should be interesting to many of you, I hope. So my name is Steve, and I work at Microsoft. I am on the ASP.NET team, and I do a fair amount of work for back-end server-side code, but I also tend to focus probably even more than that on client-side stuff. And I expect quite a lot of you deal with client-side stuff as well. Hands up if you write any code that runs inside a browser, like JavaScript, TypeScript, that sort of thing. Yeah, almost everybody. All right. So if you are like me, then when you are writing those kinds of applications that run on the client, you probably spend a bit of time thinking about what is it that's actually possible to do with a web application anyway? What are the boundaries of that possibility, and how is this changing over time? What is going to be different a few years from now? What will I be able to do then that I can't possibly do now? Well, I think about that quite a bit, and I'm very interested in how the browsers are changing, what APIs are available, and what features we can use as web developers. And if you want to know about what's going to happen in the near future, one really good way of doing that is to go and ask the people who make the browsers. And in fact, they're so kind that they've all set up their own little websites that tell us what new features are coming to the browsers in the coming years. So each browser maker has a platform status web page. This is the one that Mozilla has put up to tell us about Firefox. And that's got a very big long list of all the features that they're working on and what state they're in, whether they've shipped and whether other web browsers have shipped them, that sort of thing. It's not only Mozilla, also Google have given us this one for Chrome, chromestatus.com. This is quite nice because it tells you for each feature which actual version of Chrome the feature is going to go live into. It also gives you details about the level of consensus that's been established with other browser makers, so you'll get a good idea of whether or not a given feature is really something you can rely on across all browsers. And not surprisingly, there's also the same thing for the Edge platform, which tells us such fascinating and exciting things as there's going to soon be an ambient light sensor API, which means your web browser, your web application will be able to tell whether the user is in a light room or a dark room, which is brilliant, right? That's just what you need to do. I don't know what you'll do with that. Maybe you'll have a sort of an automatic night mode that comes on your web page or something. I don't know, but it sounds a lot of fun to me. Okay, so where do all of these specifications really come from? What's the underlying source of truth? Who's really driving this process of what goes into the browsers? Well, if you want more information about that, go to the underlying source, which is the w3.org standards list there. That is a massive, massive list of many, many web standards that are being worked on, things that have been proposed, things that have actually shipped by now. I think there's about 900 items in that list. It's very detailed, and for each item you can find lots of information, such as you can find links to the official specifications, you can find links to the mailing list discussions, and if you're really into this sort of thing, you can even go and start arguing with people on the mailing lists about what these features should actually be and what they should do. But like I said, there's a lot of them. There's about 900 items on that list, and you probably can't be bothered to read through all of them. Wouldn't it be nice if someone else did all that work for you? Well, that's what this talk is about. So I've been through that list of 900 items, and I've picked out 4 things that I think are particularly interesting to talk about. 4 things that might change the way that you build your web applications, or at least give you indications about how a web application might feel different a few years from now. So that's what we're going to do in this talk. We're going to walk through 4 different major new features that are coming into web browsers that you as web developers can make use of to build different kinds of applications. Now, the first 2 things on this list are quite big, important, deep feature areas that I'm going to go into a lot of technical detail about when I demonstrate them to you. You might have heard of them, but hopefully I'll still be able to show you something new. Finally, the 3 and 4 items on the list, they're much more small niche features that you might not have heard of, but they also provide a sense of how web applications are likely to change in the coming years. So let's get started with those. We'll start with item 1 on the list, which I think a good proportion of you will probably have heard of, but might not be using that, and that is service workers. How many people are using service workers in your current web applications? Hands up. 1, 2, 2. Okay, 2. So very, very few people are using these yet. And I'm not surprised about that because although this concept has been around for a couple of years, people have been talking about it and arguing about the specs and so on, you've not really been able to use it until roughly now because it's not been supported in browsers. But it is supported in browsers roughly as of about now. And we'll talk about that later on. But what is service workers and what do they give us? How do they change? What kind of web applications we can build? Well, they change one very important limitation of what scripts in a web application can do. Right from the very beginning of the web, it's only been possible until now for your code to run when the user is actually on your web page. Because your web page is the thing that delivers the JavaScript to your user in the first place, and as soon as the user navigates away from your page, the browser will stop running your code. Or at least that's the way it's always been until service workers. Service workers are different because they allow you to register some JavaScript with the browser that exists outside the context of a given web page. So it's not limited to the lifetime of your page. The browser can keep running your code whenever it wants to, even when the user is not on your site at all. And that allows for some interesting new types of feature. The most well-known of these features that this supports is offline. The ability to use your web application even when the user isn't got any network connection at all, but also some other features that I'll mention in a little bit to do with receiving push notifications and so on. But in order to understand this best, I think we should probably have a look at a little demo. So I'm going to build a small web application with you now, and we'll put in some service worker magic so you can get a sense of what that's like and how that works. Now, the web application I want to build is going to be this. Now, I've set it up as a news feed that looks a little bit like Twitter or something like that, but it's not specific to social media. You could imagine that this is a feed of any sort of information at all that might be relevant to your business, maybe a list of deliveries that drivers need to make or something else like that. Some set of information that changes over time. And the code that I've got in this application right now is incredibly simple because, in fact, it's just a bit of static HTML. It is this file here, index.html. There's not even any server-side code. It's just got this hard-coded static content. Plus, it references this page.js file. And what does that do? Almost nothing. All it does is it waits until the page is loaded, and then it does nothing. And what we're going to do is we're going to put in some code to register a service worker, and then we'll do some stuff with that service worker. Now, the way to register a service worker looks a little bit like this. So what I'm doing here is I'm saying, OK, browser, I want to use your service worker APIs to register a service worker in this JavaScript file here. Now, a service worker is a JavaScript file. That is how you deliver the service worker to the browser. And I'll show you that in a second. This stuff down here at the bottom, that's technically optional. I could have just deleted that and it would work the same. But I just want to display a message to say whether or not the registration succeeded or failed. So I'll save that. You are probably wondering what's in this file, serviceworker.js, so let me show you. Inside there, we have got a little starting point. OK, let's just tidy that up a bit. OK, so firstly, what's this first line, self.import scripts? This is a way of loading one JavaScript file into another. This is a new API, and it's specific to service workers. Normally, if you want to load a JavaScript file with a regular web application, you do so with a script tag, as you all well know. But you cannot do that with a service worker because there aren't any script tags. There aren't any tags at all. There isn't even a page. The service worker is not inside a web page. Therefore, obviously, you can't use a script tag. So there has to be a separate API for referencing other JavaScript files, and that's that. And then we are listening for an event called install. Now, the only thing that a service worker can do is listen for events. It's entirely up to the browser to choose when it wants to run your code, and so you have event listeners for different things that can happen. And in this case, I'm just logging a message, and then this very strange and confusing line of code there. What that is doing is it's saying, well, there's various ways that you can programmatically control when your service worker is installed, and in this case, I just want it to be installed right now without waiting for anything else. But otherwise, just ignore that. It's not very interesting. OK, so let's see if this works and it registers the service worker. I'm going to open the console and I'll reload, and we should see that indeed the page gets a message to say, yes, the service worker was registered, and then the service worker install event also fires. Now, that install event only fires once for any given version of your service worker. So if I reload, it shouldn't install the same thing again. I'm just going to get the service worker registered, but no additional install events now. And in fact, it's not until I change the code that I've got here that it's going to install a new version. So now I've changed that. When I reload, the browser will see that the code is different, so now it's going to run the install process again. So that's how we can update the service worker. Okay? But what can we do that's actually useful with it? Well, we can listen for other service worker events. And there are a few different ones, but the one we'll start with, which is the most easy one, is this fetch event. Okay? Now, the fetch event is fired whenever your application tries to make an HTTP request to your domain. And you can use that to programmatically control how you interact with the network. So here, I'm just logging a message and doing nothing else really yet. Let's see if that works. So I'll reload, and it will first install the updated version of my service worker with that fetch listener in it. And then when I reload again, you'll see that my fetch listener fires for every single HTTP request to the server. And we can use that to change what happens in terms of network access. For example, I could say, all right, I'm going to change the responses. I'm going to say for every request, which is for a PNG file, instead of fetching it from the network, I'm going to fetch this other file instead and respond as if that's what the server had returned. So now, when I come back and I hit reload, it will first install my updated service worker. Then when I reload again, you'll see that all of those images gets replaced by this silly face type thing, which is great. Now, why would we want to do that? Obviously, this is a really effective technique if your goal is to do pranks on your coworkers, but that is not the only bit of functionality that is possible using service workers. We can use this technique to enable offline access, which I will now demonstrate to you. I'm going to go through 3 different ways that we could do offline support, ranging from the very simple and not very clever to much more sophisticated. So let's get started with the most basic way that we could enable offline support in our application, and that is to simply pre-cache every single resource that your browser might need to fetch from the server. So what I'm going to do is I'm going to delete this install event that I've got there, and I'm going to add a slightly different one. And what that's going to do is it's going to have a hard-coded list of all the different resources on our domain that the browser might want to fetch, and I want to proactively cache them all up front. So I'm going to use this new API to say, okay, I want to delete any cache that's already got this name, my cache, and then I want to create a new cache, an empty one with that name. And then I want to fetch all of those resources from those URLs, and I want to store all of the responses in this cache, and then finally we'll say that this service worker is ready to be counted as installed. And then, instead of this messing around with PNG files thing, I'll have some slightly different logic that says, okay, let's just assume that every single thing we tried to fetch is already in the cache, so we can match the request against the cache and respond as if that's what the server sent to us. So we no longer need to rely on there being an internet connection because we will just serve everything from the cache. Let's see if it works, shall we? I'm going to come back and I'm going to reload, firstly to install my updated service worker. And then when I reload again, it will now be serving everything directly out of that cache that was set up when we installed. And to prove that, it's if I go over here onto the network tab, you will see that all of these requests are being served not from the network, but from the service worker's own cache. And I don't even need there to be an internet at all anymore. To show you that, I'm going to go into offline mode, and that is going to prevent the browser from making any network requests at all, not even to localhost. So if I go to any web page right now, I'm going to get the site can't be reached, there is no internet connection. And if I try to go to localhost, instead of getting that message, my service worker event fetchers will fire, and it will just return the content directly from the cache without even needing there to be an internet connection. So my page is still going to show up even though I'm offline and I'm preventing network access right now. Okay, so that's good, basic offline support, but that's very basic and naive and doesn't really cover all the scenarios that you will want to deal with. For example, what happens if the content on the web server actually changes? So let's say that there's a new news item. This is meant to be a news site, right? So let's have a new item. Let's give it some class. It doesn't matter what it is. And we'll say breaking, something happened. Okay, very good. Right, save that. I'll come back and I'll hit reload. Now, am I going to see that breaking news item? Well, no, I'm not, because firstly, I'm offline, so obviously I can't talk to the server to see it. But even if I'm online, I still will not see the updated content from the server because the application is hard-coded to just serve everything from the cache. It's not even making any connection to the server. It's got no way of knowing that there even is new content on the server right now. So I want to make my logic a little bit more refined. What I'm going to do is I'm going to say, okay, if we do have network access, then we'll use it, and we'll only use the cache if we're offline. So here's a simple implementation of that. I'm going to say, right? Firstly, we're going to try to make a net request to the real network. And if that succeeds, then we're going to use that as the response. But if that fails for any reason, then we'll fall back on serving stuff from the cache. So now I come back and I'll reload. First time it updates the service worker. Then when I reload a second time, you'll see it actually does fetch stuff from the network because I am online. But if I was to be offline, it will still work because now it's falling back on the cache. Okay, so that's an improvement, but it's still not a particularly amazingly clever solution because still bad things could happen. What happens, for example, if the user does have a network connection, so they're technically online, but it's just unbelievably slow? So it's going to take hours potentially to return the content. It's just not even practical at all. Well, let's find out right now. I'm going to simulate that by pretending that I've got typical plain Wi-Fi speeds there. And I'm going to see how long my page takes to load. So I'll go to about blank, and then I'm going to try and load the page. Now, the initial HTML comes up pretty quickly, but we're still waiting for those images. Still waiting, and they're starting to appear now. But this is taking too long. And finally, it's done. All right. So it worked, but it was very, very slow, and our users don't want to wait for that long. So we could refine our logic a little bit more than that. So what we'll do now is we'll say, again, we'll try to fetch stuff from the network, but we're only willing to wait for a certain amount of time. If it takes too long, then we're going to get stuff from the cache. So we try to make a request to the network. If that succeeds, then we'll use that response from the network, but we're only willing to wait 200 milliseconds. That's 1/5 of a second, because anything longer than that is just too long, and we don't have the patience for that sort of thing. So if it times out, then we're going to serve the content from the cache. Okay, but as well as that, we're also, even if we serve the content from the cache, we'll wait until the original network request completes, which might take ages, but when it does eventually complete, then we'll use that to programmatically update our local cached content. So the user will eventually get updates, even if they've got a very slow network connection. So let's just unthrottle this for a minute so that I can get the updated service worker into the browser. Which I've done now. And then I'm going to turn the throttling back on to the same thing that it was before. And now I'm going to change the contents on the server. So we'll have breaking 2. Something else happened. Okay. Now, when I come back and I reload, am I going to see the new breaking 2 story? Well, I should not do because it's going to take too long to fetch it. So when I hit reload, the page comes up almost immediately. After 200 milliseconds, it's being served from the cache, so the user is not waiting. But in the background, we're updating all the cache data. So if the user reloads a second time, then they will see the breaking 2 news story. So they get the benefits of immediate page loads while they also get new content eventually. Right, so what's the point of me showing you all that? It's not particularly that I'm saying that this is the one true way to do offline access or anything like that. The point is I'm saying that service workers are very powerful, and they give you the ability to exercise whatever kind of control you want over how your page interacts with the network. So you can set up whatever sort of trade-offs you want about whether the network access is mandatory or optional, and when the timeouts are, and how you're going to deal with cached content. All that sort of stuff is entirely up to you with service workers. But there are also other service worker features as well that deal with, that relate to having your code running outside the context of a page. For example, you can send push notifications from your backend to somebody's browser, and that's going to fire an event inside the service worker, even if the user is not on the web page at that time. Similarly, if the user does edits while they're offline, you can use service workers to synchronize those back to the server later when they are online, even if they're not on your page. And in the future, it should be possible to do scheduled tasks as well, but none of the browsers have actually implemented that yet. Okay, so that's service workers. As for browser support, well, it's pretty good news on that because Firefox and Chrome have already got that shipped live in production. It's also fully implemented in Edge, but it's behind a flag that the user has to turn on at the moment, but hopefully that will be on by default soon. And finally, really good news from the world of Safari. Until a couple of months ago, they had not confirmed that they were doing this, but they have, in the last couple of months, said, yes, we are actually working on this, so that is going to be a universal feature pretty soon. Okay, so that is service workers. Let's move on to item 2 on our list. Now, item 2 is another very major feature, which I think you'll have heard of, but hopefully I'll get to show you some cool new stuff that you might not have seen. And that feature is WebAssembly. So what is WebAssembly? Well, it's quite a major change to the way that we can write code inside a browser. Up until now, we've always been implementing code in JavaScript, which is a human-readable text format, which in various ways is not super efficient. So WebAssembly is a new low-level form of code that you can deliver to a browser. So it's a binary format for what you can think of as a particular subset of JavaScript, a particular subset of features that are very, very fast for the browser to JIT compile to native code, very fast for it to execute, very fast for it to verify as safe. And because that's still not fast enough, it's a binary format for representing all that, so it's extremely compact on the network as well. Now, it's not expected that you will write this by hand yourself. The idea is that you compile to WebAssembly from another language. And the easiest language you can use to compile to it right now is C or C++. So I would like to show that to you. Okay, so I've got a little bit of C code that I want to compile to WebAssembly and run inside a browser. And here is my C code, Fibonacci.c. Now, the mathematicians among you will probably know what Fibonacci series is. It's just a sequence of numbers that are defined in a particular mathematical way. Now, what those numbers are is not important at all for us in this talk, so let's just think of it as an example of an arbitrary algorithm that could be implemented in C. And the implementation that I've got looks like this. This little block of code down here is just reading parameters from the command line, and then it calls this function print Fibonacci. And then print Fibonacci goes through the process of calculating all the values and then just logs them all to the console. Normally, if you want to run C code, you compile it to make a native executable using a C compiler, such as the GNU C compiler. And here I'm saying, okay, I want to compile Fibonacci.c, and I want to execute a native binary called Fibonacci. So we'll run that. And very quickly, we've got the binary, we can run it, and then we can say, give me the first 10 terms, and it will print them out to the console. Okay, pretty straightforward. But can we compile that to WebAssembly? And the answer is, of course, yes, we can, and quite easily. But we don't use GCC. I'm instead going to use EMCC. MCC is the Emscripten C compiler. And that is going to take in this C source code, and it's going to output WebAssembly in this particular case. It can also output ASM.js, which is a particular type of JavaScript, but I want a WebAssembly binary, so that's what that flag does, and it's going to wrap it all in a JS file called Fibonacci.js. So I will run that, and when that runs, it's going to produce the following output. It's going to produce these two files here, Fibonacci.js and Fibonacci.wasm. The wasm file, the WebAssembly file, is the actual binary. So that's the very compact binary format for this code. And you might be thinking, hang on, 48 kilobytes does not seem very compact to me because you only had 20 lines of source code. Why is that now a 48 kilobyte file? Well, the answer to that is it's not just our application code that's in there. There's an entire C runtime in there as well, and that's what's taking up 99% of that 48 kilobytes. So you could build a much larger application than this, and it wouldn't necessarily get too much bigger than that 50 kilobyte size. We've also got this Fibonacci.js, which is a little wrapper around that, and that deals with being able to bootstrap that code and make calls into it from JavaScript and get calls back out and all that sort of stuff, and that gets generated for us. So if we want to run this, we're going to need to embed it into a web page, and that's what I've got here. I've got an HTML file, and all that contains at the moment is this script tag that's going to load Fibonacci.js, and it's also going to set up some arguments that are passed into it, which is equivalent to command line parameters. So let us start that running, and we'll see if it actually works. I will run that in my browser, and we will look in the console, and we will see that indeed it actually does run that C code, but now in the form of WebAssembly, and it's printing out the Fibonacci sequence. But how does that work anyway? It's quite hard to make sense of it if you're just looking at these files on disk. We've got this WASM file here, but like I said, that's a binary file format. It's not really human readable. But we can produce a human readable version of it, sort of, by passing this debug flag, -g. And when that runs, we will see that we now have this WAST file, WebAssembly text file, and that gives us a kind of human readable version of the contents, although I admit it does depend on what kind of human you are, whether you can read this. It's not easy to make sense of. It's quite low level. It does look like assembly code, but like I said, it's effectively a kind of subset of JavaScript. And if you look carefully in there, print Fibonacci, you can even see your own code, and you can see things like which line numbers different bits of the code correspond to. Okay, so we can compile some C code to WebAssembly, which is nice. And there is also work going on being able to compile other languages to WebAssembly. For example, it's possible to compile Swift or Rust or Go to WebAssembly, kind of. It's a bit of a hard process at the moment, but theoretically, anything that uses the Clang toolchain to produce LLVM bytecode can be compiled to WebAssembly. So that's really nice, and if you think about it, theoretically, it would even be possible to do something like take a .NET runtime and compile that to WebAssembly. And if you could do that, then you would have a full .NET environment inside the browser, which means you could load and execute .NET assemblies, which sounds like it would be pretty awesome. Maybe you think that sounds a bit implausible. Maybe 10 years from now, maybe we might be able to do that, but probably not today, right? Well, how about we have a go? Shall we see if we can compile an actual working .NET runtime into WebAssembly so that we can run .NET code inside a browser? So, in order to do that, I want to show you something. I want to show you something called DNA. What is that anyway? Well, I've got this directory here full of C source code. Quite a lot of C source code. Deals with things like JIT and heap and generics and all this sort of stuff. What's all that then? Well, this is a .NET runtime. It's not the regular .NET runtime. It's not .NET Core or the full .NET framework. In fact, it's a third-party implementation of .NET called .NET Anywhere, or DNA for short. Now, this is not very widely used. Very few people have even heard of the fact that this exists, but it does exist, and it actually works. It genuinely can load and execute regular .NET assemblies, and the performance is quite decent, and it's got almost all the sort of functionality that you would want to run regular .NET code. It's not designed to be compiled to WebAssembly by any means at all. In fact, DNA predates WebAssembly by several years, so certainly that's not what it's been designed for. But because it's just written with fairly basic C code, it doesn't take very much to get it to compile through the Emscripten C compiler. So that's what I did. And when I did run that, here's what I got out of it. I got these two files, dna.js and dna.wasm. And that WebAssembly file there, which is quite a bit bigger than the one we had before, contains a fully working .NET runtime. And that can deal with all the stuff that you need. For example, being able to load and parse .NET assemblies. It deals with all the JIT compilation. It deals with memory management, garbage collection. All that sort of stuff is in there. And then we've also got this wrapper around it that knows how to interop with regular JavaScript code. So let's have a go at running that then, shall we? I want to run that again inside a web page. So I've got another HTML file here. This one is going to load the dna.js file, and we probably need to pass some arguments to it, but haven't figured that out yet. Let's just run it first and see what happens. So let's start up a web server in that directory, and then I will be able to go to this application on port 8080 and see what comes up. And we will see that it is in fact working. Look, it's trying to run the DNA runtime, and DNA is saying, okay, please tell me which .NET executable you want me to execute. Sounds pretty promising. Okay, so we need a .NET executable to feed into it, and that's okay because I've got one right here. I've got everyone's good old friend Console App 1 that we know and love, okay? Console App 1, as you all know, does the very wonderful thing of printing out hello world to the console. And we can build that using VS or command line. So I'll build it, and that will produce a .NET binary, a DLL. And if we have a look on disk for that, we'll see that it's in, where is it? Bin, debug, netcore app, blah, blah, blah. And here it is, consoleapp1.dll. It is 5 magnificent kilobytes of compiled .NET code. And I want to feed that into DNA. So I'm going to go to its config here, and I'm going to say, all right then, what I want you to do now, DNA, is I want you to load consoleapp1.dll to execute it. Now, because this is running inside a browser, it can't read files directly from my disk. It can only make requests to URLs. So when it wants to load consoleapp1.dll, I'm configuring it to say, okay, you can get consoleapp1.dll from this URL here. And also, you're going to need to be able to load this corelib.dll, which is another .NET assembly which contains implementations of all the low-level .NET stuff like strings and lists and that sort of thing. Okay, so given that we've configured this now, come back over here, I'll hit reload one more time, and indeed it actually works. We are now actually running our .NET code inside the browser. And to prove that that really does work and can run arbitrary C# source code, I'm going to come back over here, and I'm going to drop in this time a C# implementation of Fibonacci there. quite simple stuff. And I'm going to say I want to print Fibonacci, first 10 terms, please. I'll do Shift F6 to reload, and then I'll come back, and when I run it again, you'll see it does actually run the C# Fibonacci stuff. Okay. So I think that hopefully illustrates some of the pretty awesome power of WebAssembly. We've been able to bring an entirely new language and runtime into the browser with very little work. And if you're anything like me, you probably look at that and you think, that is interesting, isn't it? Running .NET inside the browser. Wouldn't it be interesting if there was some sort of framework for being able to run client-side .NET applications? Because then, to write a web application, I could write all of my code in C#, both the back-end code and the front-end code. I could share code between them, and I wouldn't have to deal with JavaScript and TypeScript and Webpack and NPM and all that stuff. It would just be .NET everywhere. Wouldn't that be cool? So that's what I thought too. And I thought, all right, well, let's have a go. Let's see if we can make a little experimental framework that runs .NET inside the browser, and we'll see how well that actually works. So I want to show that to you now and give you a sense of what that could be like. Now, I will caution you that this is not a shipping product. This is just an experiment. No one's promising that anything like this will ever become real, but it's interesting at least, and I want to know what you think about it. So I'm going to create a new project now, and I'm going to choose to build a Blazor application. So what is Blazor then? It's a rich client-side application with C# and Razor running inside the browser. Okay, well, let's give that a name, My NDC App. Okay, let's start that. And so that's going to create a new project for us, and hopefully it's going to restore all the packages and get ready to run and everything like that. And I am going to launch that in a browser before I show you any code. So when that comes up, you will hopefully see that this looks like a fairly typical single-page application. And here it comes round about now. Okay, so it's got the usual kind of features that you'd have in a single-page application. Like I've got navigation, client-side navigation, that is. I've got the ability to render components that can be nested inside each other. I've got an example of a component here that fetches some data from an API backend and renders it. I've also got an example of a component that listens for clicks on buttons and just counts the number of times that you have clicked. Okay, pretty straightforward stuff. But what's the code for this like? I mean, we could obviously build this sort of thing in a JavaScript framework like Angular or React or that sort of thing. But what have we got over here? Well, this is quite different because in this application there is no JavaScript whatsoever. All we have got is C#, we've got some CS/HTML, that's Razor pages, and we've also got a little bit of HTML and CSS that are used for layouts and styling. And as for the actual component code themselves, well, let's have a look at this counter component here, and you'll see that it's a Razor page. Razor combines both HTML and C#, and in this case I'm declaring a variable to track the number of times that you've clicked a button, and then I've got a method that increments that count. I've also got some HTML that displays the current count property, and then a button that when you click it is going to increment that count. So pretty basic stuff, and it seems to kind of work, doesn't it? But would this really work? Could you genuinely build a non-trivial application like this? Well, I'll need to try building something so that we can find out. Now, as you know, as a very important matter of professional ethics, I need to demonstrate to you an example of a to-do list application. So I'm going to do that right now. I'm going to add a new item here, and that's going to be a Razor page. So I'll call it to-do list.cshtml, and I'm going to put a little bit of content in there. To-do list, okay? Now, I want some way of navigating to this. At the moment, I've only got these 3 links over here. So I'm going to go into the component for the nav menu there, and I'm going to copy and paste this list item here, and I'm going to have another one that links to to-do list. And then I'm going to not do that. I'm going to change the text on it to display to-do list. Okay, and then as soon as I hit save in my IDE here, we will see the browser immediately updates, and we've got to-do list on the menu there. And I'll click on that, and that's now going to render the to-do list component in the main part of the page. Okay, very good. Let's add the actual to-do list implementation here. And I'm going to start by putting in a bit of C# code. Because it's C#, I want to model to-do items as classes. So I'm going to have a class called to-do item. And each to-do item is going to have a couple of properties. I'm going to have a string called text, and I'll also have a bool property called isDone. And I want to model a list of those things. So I'm going to have a list of to-do items called to-do items. And I'm going to make that a new list. Okay, very good. And what can I do with that then? Well, the first thing I want to do is display the number of items in the list. So I'm going to display to-do items dot count. And I'll hit save, and we'll see that there are 0 items in that list initially, like you'd expect. And I also want to actually display the list contents. So I'm going to do a bit of razor code here to say for each item in to-do items, I want to display the item.text value. Surprised I'm not getting IntelliSense there. Okay, well, okay, at the moment the list is empty. So before we can do anything else, I want to add a button that adds items to that list. So let's have a button with add item on it there. And you can see that initially clicking that button does absolutely nothing because I haven't associated any behavior with it. If I was writing some very old school JavaScript, I could put onClick equals, and then I could start writing some JavaScript in there if I wanted. But because this is a client-side razor, I can put some C# code in there. I can say, okay, let's get the to-do items, and we will add a new to-do item, and I'm going to set the text on that item to whatever. Okay, so I'll hit save now, and then when I click on this button, you will see it displays the item text, or it would, but for some strange reason, it's displaying item dot because I did not put that important symbol in my source code. So let's try that again, and there we go. Now it's displaying the actual property from my item. Okay, very good. I don't really like the fact that I'm embedding all this code in an HTML attribute. I think I would rather be having C# methods, so I'll have a C# method called addItem, and I'm going to take my code from there, and I'm going to put it into that method. And in order to invoke that, I'm going to use a bit of shorthand to say onClick add item. That looks a little bit better, and it should still behave the same as before. Right, that's good. But I don't want to hard code this string whatever. That's not very useful in practice. I want the user to be able to type in some text. So I'm going to have a text box. I'll give it a placeholder type here. Okay, and I want some way of capturing whatever the user types into that text box. Now there's a few different ways that I could do that, but one simple way is I'll have a string property called next item text. Okay, and I'm going to bind the value of this text box to next item text, so we can see whatever the user has typed in. And then, instead of using the string whatever, I'm going to use next item text. Also, when the user presses the button, I want the text box to get cleared out so they can type the next thing in, and I'm going to achieve that by setting next item text back to null or empty string. All right, let's see if that works. So now I should be able to type in here, and indeed it does actually work. It puts my text into the to-do item there, and it clears the box out automatically. So that's pretty good. What else do I want to do? Well, 2 more features. I firstly would like to be able to edit these things after I've typed them in, because I might have typed it wrong. And I also want to have a checkbox for marking items as done or not. And I can do that by modifying my razor code up here. So let's have a input that is bound to the item.text value. And I also want a checkbox that is an input type equals checkbox, and I want to bind that to the item.isDone property, like that. So now the user can come along and they can type in some items and they can mark them as done. That's very good. But you can't really see anything happening when I check these boxes. Nothing meaningfully seems to change. So to show you that something is actually happening, let's say that instead of displaying the total number of items in the list, I want to display the number of remaining incomplete items. And I can do that with a little bit of link code up here. I can say, all right, I want to display the remaining count, and that is going to be the count over all the items where the item is not done. So I'll hit save on that, and now when I type stuff in here, I can check off these items, and you'll see that remaining count goes up and down in the way that the user would expect. All right, so that's pretty cool. We have written, what is it, roughly 30 lines of very simple C#, and we've got a straightforward but functional list editing application there. And you could go on building something much more sophisticated than that if you want to. But I know some of you are probably thinking, well, that looks kind of nice, but it's not really practical, is it? Because there's going to be all kinds of problems with that. For example, you can't seriously ship an entire .NET runtime inside a web page, can you? Like, and all the standard libraries and everything. What's that going to be? That's going to be hundreds of megabytes. There's no way you can do that. So let's have a look. Let's see how big this application actually is. I'm going to do a hard reload on the network tab, and you'll see that this whole application there has currently come out at 332 kilobytes. And that is including everything. That's including the .NET runtime, that's including the core libraries that it's using, it's including our application code, it's even including the Bootstrap CSS that we're using for the page layout. So that's entirely reasonable. Plenty of other single application frameworks will produce applications that are bigger than that, and that's without even shipping some kind of managed code runtime in there. So that is eminently practical. Okay, that's good. But you know, I know that you may be also thinking, well, that's all very well, but you know, only the very latest web browsers support WebAssembly, you know. I need to support older web browsers that don't support WebAssembly. It's not going to work on those, is it? Well, let's find out, shall we? I'm going to open up Internet Explorer 11, which very much does not support WebAssembly in even the most slight kind of way. And I'm going to paste in our application URL there, and we'll go to that, and what happens? It works. The application just comes up, and it has all the same identical behaviors as we had before. So how on earth is that possible? How is a WebAssembly application running inside a browser that doesn't even support WebAssembly? And the answer to that is that basically WebAssembly is a really cool technology. It's been designed so that it can fall back easily on regular JavaScript. So when the mscriptum compiler produces the WebAssembly version of the DNA runtime, we can also, with a single compiler flag, make it generate a ASM.js version of the same thing, which behaves identically. And that will work on down-level browsers. Now, it's a bit larger, and it doesn't run quite as fast, but it does work. It's certainly fast enough just to display user interfaces, and it produces identical behaviors. So it's better if your user does have WebAssembly support, but it's still going to work even if they don't. OK, so that's pretty cool. We've now been able to build an application with .NET in there, but we could go even further than that. A couple of months ago, I showed this demo to some of the people on the ASP.NET team, and they got quite excited about that, trying to think about ways that they could make it even better. And we had a little hackathon on the team a few weeks ago, where people implemented a whole bunch of different and interesting cool features. For example, the ability to do interop between .NET code and JavaScript in a really friendly way with IntelliSense and everything. That was great. But another thing, which I think is the best thing that was implemented, is debugging support. Now, a few months ago, I had no idea if or how it would be possible to make a debugger work with this sort of a runtime. But a couple of people on the ASP.NET team, Stefan Holter and David Fowler, who some of you may have heard of, got really into this and started being determined that they were going to find some way of getting debugger support for that. And they actually did it. So I want to show you that now. You'll be the first people to see this. It is pretty cool. So I'm going to switch over to a different Blazor application here. It's very similar, but this one has been split into 3 projects. We've got a server-side part, which is a regular ASP.NET application. We've got the client-side part, which is the Blazor application. And we've got a shared class library, which was just a way of proving that we can share things like domain classes in between both server and client, and it all works as you'd expect. But that's not really what I want to show you. What I want to show you is this debugging thing. So I'm going to start that running inside a browser right now. And when that pops up, you'll see it's got quite a few other little tech demos that people have put in just to prove that different things work. For example, the ability to invoke third-party JavaScript libraries in a friendly, IntelliSense-driven way from C#. That's what that button is doing. It's calling the Bootstrap modal dialog code. Okay, that's nice. But it's not really what I want to show you. What I want to do is add debugging support to this. So I am going to get another browser window, doing a little bit of rearrangement of my browser windows here. And I am going to go to a special URL. And when I do that, the Chrome debugger shows up. But it's not just showing JavaScript code now. It is showing the JavaScript code, but it's also showing our .NET code. So you can see we've got the .NET DLLs listed down there. And if we expand this, we can see all of the C# source code that's in them. So we can explore all of our .NET implementation here in the middle of the Chrome debugger. And not just the CS files, but also the Razor pages as well. For example, here is the page for the component that I'm displaying right now, the Bootstrap component. And down here, you can see the event that fires that causes the modal dialog to actually get shown. And I can even set a breakpoint on there. And when I hit this button now, you will see that it hits that breakpoint, and we can then start doing things like stepping through all of the .NET implementation. So let me just show you that one more time, just because I really love it. So I've hit the breakpoint, and then I can hit go, and the modal dialog actually pops up. So there is a long way between what exists in this little demo here and anything that you could use to build a production application. But I would be very interested to know if any of you would really find that compelling. So if you want to actually try this out yourself, you can go to this repo on GitHub there, and you can actually download a Visual Studio extension that gives you the project template, and you can actually start trying it out for yourself. Now, if you do that today, you're going to get a version that's about a month old and doesn't have the debugging support, but hopefully over the next week or so, I'm going to merge 2 different repos that we've got and add all the latest stuff into there and debugging support and everything like that. But once again, no promises that this is going to be a real thing. It sort of depends on your feedback and what people really want to do with it. Okay, so that is WebAssembly. As for actual browser support right now, pretty good news on that. Chrome and Firefox have already got it live and shipped, but it's also fully implemented in Edge and Safari as well. In Edge, it's currently hidden behind a flag that users have to turn on in settings, but hopefully that will be on by default quite soon. And as far as Safari is concerned, as far as I understand, it depends on what version of the operating system you're on. So I think if you are on iOS 11 or later, or whatever the corresponding version of macOS is, then you've got WebAssembly on there, but it's certainly fully implemented and ready to go there. So that's great news for everyone who wants to do WebAssembly. But even for older browsers, like I said, we can fall back on Awesome.js and get the same behavior. Right then, that's WebAssembly. Let's move on to the last 2 topics now. Like I said, these are a little bit more niche. You might not have heard of them before, but they give you a good sense of how web development might evolve over the next couple of years. And the first one I want to show you is called Credential Management. It sounds unbelievably boring, but it's actually quite useful. Now, since the beginning of time as web developers, we've always had to deal with credentials. That is, we've been implementing login screens and user registration and sign out and I forgot my password and all that kind of boring stuff that you have to do over and over again. And up until now, browsers have done almost nothing to help you with that. But credential management is a new set of APIs that allows the browser to actually understand the concept of credentials and do something useful for you. Specifically, it allows you to do things like automatically synchronize login states across a user's devices, so that if they register on a desktop with your application, then as soon as they open your site on their mobile, they're already logged in and they don't have to do any steps at all. They're just sharing their account across 2 devices automatically. It also allows the browser to do things like display native UI for account pickers and other stuff that I won't really have time to discuss in detail. But again, I think the best way for you to understand it is for you to see it. So I'm going to switch over to our final demo application right now. And this gives me an opportunity to show you a little business idea that I've been working on in my spare time. I'm hoping that I'm going to get extremely rich out of this. I think there's a lot of potential in it. And it's a new software as a service startup called CEO Portal. Now, the idea with CEO Portal is that it's for company CEOs, you know, the big, powerful titans of industry who are very, very busy people, and they've got lots of important work to do. And the idea with this website is that they can go to this one website, and it gives them the ability to do all the stuff that a CEO needs to do in their normal line of work. So if I bring that up in a browser, you will see that we've got some pretty good corporate web design going on there. I think CEOs are into that sort of thing, and it allows them to do all the stuff that they need to do on a day-to-day basis. Now, as you probably know, CEOs are very, very fussy about IT security stuff. They might not know what it is, but they know they want it, and so we need to have a very, very robust and streamlined user registration and login system. And so that's what I've got here, and I've implemented it using the Credential Management APIs. So let me show you what the application is actually doing using the debugger. So when I first load this page, this is what code runs. I'm using the Credential Management API to say, right, browser, I want to use credential management. I want to know, have we got any credentials stored for this user already? And the browser is going to say, well, here's what I've got for you, undefined. No, we do not have any credentials stored for this user yet. And so my application is going to display this logged out kind of state that you can see right now. And the CEO is going to see this and they're going to think, yes, this is exactly what I want. I need to register myself with that right now. And then they're going to click on the register button and they'll type in a username and they'll pick a password and they're going to click on the register button. And when they do that, we're going to run this code. I'm going to first instantiate a new password credential object. There are various different types of credentials that exist within the credential management world, for example, federated credentials and other things like that. But the simplest one is a password credential, and that is just a username and password. And we can populate one of those using data that's been entered into an HTML form, and that's what I'm doing right there. So when I step over this line, we'll see we've now got a password credential object. And we can see we've got this username, Steve, and we've got this password, password1, that I always use for everything. Don't abuse that info, please. And then we are going to store that in the browser. So I'm saying, browser, please store this credential. And when I do that, it's going to pop up a little dialog. Do you want me to save your password for the site? And the CEO is going to think, don't know what that means, but that button is blue, so I'm going to click that button. And they will do that. And the browser has now stored that credential for them. Okay? And so now the user has got a stored credential and they're registered, we can switch over to a logged in view. So now the application is saying, welcome, Steve. Which of these popular executive activities do you want to perform today? And the user can go ahead and do whatever stuff they need to do. Okay, so that's pretty good. But there's more that we can do than that. For example, what happens when the user comes back later? I'm going to click on this reload button, and then this time it's going to behave a little bit differently. When we go into this getting saved credentials, we'll see that instead of undefined, we now have the same password credential object as we got before because it's been stored, so we can automatically bring up the signed in view without having to ask the user to do anything. And in fact, every time I reload, you'll see that this little message appears in the top corner, signing in as Steve. Okay? Because the browser understands the concept of credentials now, and it can prompt the user in whatever way makes sense for the particular type of browser or device that the user has got. And also, the user can deal with things like having multiple accounts. So if I register a new user right now, I'm going to have Bert, and I'll register that. Do you want to save Bert? Yeah, sure. Now when I go to signing in, you'll see that some native UI appears this time. This is provided by the browser, and it allows the user to pick which one of the saved credentials they want to use. So they can say, okay, today I'm going to be Bert, and then I can sign out, and then today I'm going to be Steve, and life continues as before. But they've got a fairly straightforward way of dealing with having multiple accounts. Okay, let's clear away Bert, and we'll just have Steve now. All right, so that is the credential management system that is available now, or becoming available soon. If we think about the actual browser support that's available right now, it's a bit early days, I'm afraid to say. So like I've just shown you, this has already shipped in Chrome. Now, Edge and Firefox, they're a little bit behind on this. They have acknowledged that it's a feature that they might be interested in implementing, but they have not necessarily even started. They've not told us they have. Slightly better news from the world of Safari. They have at least acknowledged that this is a feature that they are actively building support for. So hopefully it won't be too long until we see this become a real thing. Okay. So that is credential management. And like I said, there are some cool things that this allows you to do that wouldn't have been possible before. For example, the browser can automatically synchronize those credential objects among all the devices that is owned by a given user. Now, as for how that actually works, how it knows which user has the same devices and deals with actually transferring the data, that's not our problem. Okay? As long as we're not the people who are implementing the browsers, we don't have to care about that. We can just benefit from the fact that that does, in fact, work. It does only work within the devices from a single vendor. So, for example, if the user's got an Android phone, it will synchronize with Chrome on the desktop. If they're in the iOS world, it'll be synchronizing with Safari on the Mac. Maybe at some point in the future, we might deal with some sort of cross-browser, cross-vendor synchronizing thing, but I don't think there's any specific plan to make that work right now. Okay, that's credential management. Finally, let's get on to the fourth and final thing that I want to show you, which is another very valuable feature that I think you'll all benefit from, and that is payment requests. The idea with this is that since, again, the very beginning of web development, there's been one thing that web developers have desired above all else, and that is to get money from people who come to their web pages, obviously. But up until now, it's been a really horrible experience, both for developers and for visitors, because in order to get money from someone, you have to do awful things like ask them to type in their credit card number manually and type in their delivery addresses manually and all that kind of stuff. And it's awful. And you end up with these like 20-stage checkout processes, and 90% of users don't even bother to complete the process, and then you don't get their money, which is a tragedy. And I think you deserve better than that. You deserve that money, and that's what payment requests is hopefully going to make happen. Compare this experience with what happens in a native mobile app. If you're in a mobile app and it wants some money out of you, it does not ask you to type in a credit card number. It just says, please confirm that you want to send $4 to whatever, and the user presses their fingerprint on and the money is sent. That's as simple as the user experience is. Wouldn't it be nice if your web application could do it in just as simple a way as that? That's what payment requests is supposed to do. It gives you the ability to have a similarly nice user experience as a native mobile app. The actual way that the user confirms the payment varies from one type of device or browser to another. For example, if they're on a mobile, it probably would ask them for a fingerprint. On desktop, it might use some other way to confirm who they are. But you don't have to ask for them to type in the credit card number. It's going to use the information that the operating system already knows about this user. So let's see this actually working then, shall we? Okay, this brings me to how I want to monetize CEO Portal and how hopefully I'm going to get very rich from this. So imagine the scenario. The CEO has registered, they've signed in, they've started doing some stuff, and what kind of thing do CEOs like to do? Well, in my experience, the sort of thing that CEOs are into is reviewing key financial documents. I don't know why, but they love that sort of thing. So they're probably going to click on this button, review key financials, and what are we going to do? We're going to say, aha, that's a premium feature. If you want to see your shareholder value report, you can unlock it now for just 50 gems. And the CEO is probably going to think, yeah, that's an excellent deal. I definitely want to see my shareholder value report. But hang on, oh no, I've got 0 gems. I'm going to have to get some more gems. So they'll click on the Get More Gems button, and that takes them into the gem store. Okay, so they're going to think, how many gems do I want to buy? Well, for whatever reason, I don't know what it is, but somehow subconsciously my attention is being drawn to this 50 million gems option. It is the most popular one after all, so it's probably rational that I would want to buy that one. Okay, so the CEO is obviously going to click on the 50 million gems button. And when they do that, we want their money. How are we actually going to get the money out of them? Well, let me show you the code that we are going to run. Okay, so I've got this method down here called buy gems. And what's that going to do? Well, firstly, it's going to start by computing how much money we're going to try and get from them. This is an important thing to understand about payment requests. It does not calculate stuff for you. It's not working out taxes or delivery prices or anything like that. It's completely up to you to do all the calculations that you want. So here I've got this particular shipping amount. I'm adding on a mandatory 20% tip, which I think is fair, and I'm hoping that that's going to catch on in e-commerce generally. And then we're going to work out the total price that we're going to take from the user. And then we instantiate a new payment request object. And that allows us to configure a few different options. For example, we can configure which payment methods that we're willing to accept. In this case, I'm only accepting credit card payments, but you could also accept things like Android Pay or Apple Pay or whatever else you think a given device might support, and configure that in various ways. We also set up which line items are going to appear on this order. So we've got the number of gems, shipping, blah, 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 blah. And then finally, we're going to say we want the user to give us shipping details so we know where we want to deliver this to, which might not make sense in this case, but obviously in other cases it might make sense. And finally, we tell the browser that we want it to show that payment request. The way that the user interface actually looks depends on the browser and the device. That's not up to you as the developer, that's up to the device. But you don't need to think or care about that. All you need to care about is that at some point in the future, you're going to get a call back, and it might be a success with all the payment information, or it might be a failure, maybe because the user cancelled or something like that. Okay, so let's do this now. I'm going to click on the big flashing button, and it's going to run that code, and it's going to hopefully show a payment request. So I'll click that now, and this is what is going to appear. This is some user interface that in this case is supplied by Chrome, and it's going to display the order summary so we can see what we're actually buying and what we're paying for. We can see shipping address, where the user can pick from their existing saved shipping addresses or enter a new one if they want to. We can choose a shipping method, such as in this case online delivery, as if there's any other way to get virtual gems. And then finally the user can choose their payment method or enter a new credit card, that sort of thing. And when they've eventually done all that stuff, they are, as always, going to click on the blue button because it's the brightest one, and then we're going to ask for confirmation. The way that confirmation works, again, like I keep saying, it's going to depend on what type of device it is. In this case, Chrome is going to ask me for the CVC number to confirm that. And when I do confirm it, the browser is going to return all the payment information to you. it is not actually making a transaction for you. It does not contact a bank in some way. It does not somehow get money into your account automatically. All it does is it supplies the payment information that you can then pass through to whatever payment provider you already use. We've got the billing address, we've got the shipping details, we've got the credit card number and all that sort of stuff, and hopefully you know how to use that to get some money from the user. Okay. Other browsers may display things differently. This feature is already available in Edge right now, as well as Chrome. I've just shown it to you in Chrome. It's also already available to the public in Edge, but the user interface looks different. It brings up Microsoft Wallet in that particular case. It's coming soon to Firefox. We don't know how they're going to make this look or what they're going to do for confirmation, but hopefully it'll be there soon. Not quite such great news from Safari this time. They have at least acknowledged that the feature exists. Until a couple of months ago, they were just complete silence on this. They didn't even acknowledge that there was a thing called payment requests. But now they have acknowledged it, and they've said they're considering it. So, you know, hopefully they're going to put that into their browser pretty soon, and then it'll be another thing that you can use. Of course, there are always going to be people that use older browsers, and you don't want to necessarily give up on their money. So you're probably still going to have to implement a traditional checkout flow with manual entering credit card numbers and stuff like that. But the users who do have browser support for this will probably have a higher conversion rate because, you know, the user just has to click a button, they get money to you. There's going to be fewer opportunities for them to get that wrong. Right then. So that is as much as I've got time to show you. We've gone through 4 of the major new features that are coming out and making available to web developers in the immediate future, many of which are already available in browsers right now. So let's finish off by imagining what your next mobile or desktop web application might look like and what it might do. Well, you could use service workers to make your application load immediately, even if the user's offline or even if they've got a very slow network connection. You could also use service workers to deal with receiving push notifications from your backend server and doing stuff even if the user's not on the page. And similarly, if they did something while they were offline, then when the network connection comes back up later, even if they've navigated away, you can still do stuff to synchronize it back to your server. That's all service worker features. You could also use WebAssembly in order to bring your own choice of language and runtime into the browser so that you can implement your application with whatever technology you choose. You could also use the Credential Management APIs to ensure that your users are always logged in across all their devices without having to manually remember their passwords and type them in on tiny little mobile phone screens. And finally, you could use the payment request system to get money out of users with a very simple gesture such as a fingerprint confirmation. So I hope some of that is of interest to you and has given you some ideas of how you might like to add some cool new stuff to your next web application. We don't have time for anything else, but I hope that was fun to you. Please remember to evaluate this session as you go out through the door, and otherwise just really enjoy the rest of your conference. Thank you.